Adding a second 480/1000 amp service, especially for a high-demand application like an engine dyno, raises several important considerations. Firstly, a key issue to be aware of is the potential violation of electrical codes. The National Electrical Code, or NEC, generally prohibits multiple services for the same building, particularly when they exceed a certain capacity. This is a primary concern that needs to be addressed with local authorities and qualified electrical engineers. Secondly, overloading the transformer is a significant concern. Multiple services can put excessive load on the transformer serving the building. This can lead to overheating and potential failure of the transformer, which is a costly and dangerous situation. Careful assessment of the transformer's capacity is essential. Thirdly, increased fault current is a risk. Adding another high-ampacity service increases the potential for high fault current in the event of a short circuit. This elevated fault current can damage equipment and pose a serious safety hazard to personnel. Adequate overcurrent protection is crucial. Fourthly, grounding issues can arise. Multiple services can introduce grounding problems such as ground loops or unequal grounding potential. These issues can interfere with the proper operation of electrical equipment and create safety hazards. A properly designed and implemented grounding system is vital. Fifthly, inductive interference should be considered. Multiple services carrying high current can generate magnetic fields. These magnetic fields can interfere with nearby sensitive electronic equipment, disrupting their operation. Shielding and proper routing of conductors can help mitigate this. Specific to engine dynos, several additional factors come into play. Firstly, short-circuit currents are a major concern. An engine dyno can generate very high short-circuit currents, which must be properly handled by the electrical system. The system needs to be designed to safely interrupt these high currents. Secondly, reactive loads are significant. Induction motors, such as those used in engine dynos, draw significant reactive power. This reactive power can affect the voltage stability of the system and increase energy losses. Power factor correction may be necessary. Thirdly, harmonics are a potential problem. Engine dynos can generate harmonics which can distort the waveform of the power supply and cause problems for other equipment. Harmonic filters may be required to mitigate these effects. Plaques and directories are essential for safety and compliance. The NEC requires plaques and directories to clearly identify the location of each service and its capacity. For multiple services, it is critically important to ensure that the plaques and directories are accurate and well maintained to avoid confusion or errors, especially during emergencies. Given these potential issues, several recommendations are essential. Firstly, consult with a qualified electrical engineer. An engineer can determine the feasibility and safety of adding another service and design the system to meet code requirements. Secondly, obtain proper permits from the local authority. This ensures compliance with all applicable codes and regulations and avoids potential fines or legal issues. Thirdly, install appropriate equipment. This includes transformers, circuit breakers, and grounding systems to handle the additional load and fault currents safely and effectively. Fourthly, coordinate with the utility company. This ensures that the transformer serving the building can handle the increased load and that the utility's infrastructure is adequate. Fifthly, regularly maintain and inspect the electrical system. This helps prevent potential issues and ensures that the system continues to operate safely and reliably. To further elaborate on the issue of multiple services and NEC compliance, consider the specific sections of the code that might be relevant. NEC Article 230.2 generally requires that a building or structure be supplied by only one service. However, there are exceptions to this rule, such as for large capacity installations or where different occupancies exist in the same building. The engineer should carefully review these exceptions to determine if the proposed installation qualifies. Regarding overloading the transformer, a load study should be performed to accurately determine the existing and proposed loads on the transformer. This study should consider both the continuous and intermittent loads, as well as any future expansion plans. The transformer's nameplate rating should be compared to the calculated load to ensure that it is not being overloaded. The transformer's impedance should also be considered when calculating fault currents. To address the increased fault current, a thorough short-circuit study should be performed. This study should consider the contribution of fault current from all sources, including the utility, generators, and motors. The interrupting rating of all overcurrent protective devices, such as circuit breakers and fuses, should be adequate to handle the available fault current. Coordination studies should also be performed to ensure that the overcurrent protective devices operate selectively to minimize downtime. Addressing grounding issues requires a properly designed grounding electrode system. This system should comply with NEC Article 250 and should provide a low impedance path to ground for fault currents. Ground fault protection should be provided to minimize the risk of electrical shock. Bonding of all metallic equipment and enclosures is also essential to ensure equipotential grounding. To mitigate inductive interference, consider the routing of conductors. High current conductors should be routed away from sensitive electronic equipment. Shielded cables can also be used to reduce electromagnetic emissions. Filtering can be used to remove unwanted frequencies from the power supply. The specific issues related to engine dyno should be addressed with specialized equipment and techniques. To handle the high short-circuit currents, consider using current-limiting fuses or circuit breakers with high interrupting ratings. Reactive power compensation can be achieved with power factor correction capacitors or active harmonic filters. Harmonic filters can also be used to reduce harmonic distortion and improve power quality. Ensuring that plaques and directories are accurate and well maintained is a simple but important task. The plaque should be clearly labeled with the service voltage, amperage, and interrupting rating. The directory should provide a detailed description of the circuit served by each service. The plaques and directories should be located in a conspicuous location where they can be easily accessed by qualified personnel. The electrical engineer should be involved in the design and installation of the electrical system. The engineer should review the plans and specifications to ensure that they comply with all applicable codes and regulations. The engineer should also inspect the installation to ensure that it is properly installed and grounded. Proper permitting from the local authority is essential to ensure that the electrical system is safe and compliant. The permitting process typically involves submitting plans and specifications to the local authority for a review. The local authority may also conduct inspections to ensure that the installation complies with the approved plans. Regular maintenance and inspection of the electrical system is important to prevent potential issues. Maintenance should include periodic inspection of all electrical equipment, tightening of connections, and testing of overcurrent protective devices. Infrared thermography can be used to detect hotspots in electrical equipment. A comprehensive understanding of the NEC is critical for ensuring the safety and compliance of the electrical system. The NEC is a complex document that is updated every 3 years. It is important to stay up to date with the latest edition of the NEC. Training and continuing education are essential for electrical engineers and electricians. They should attend courses and seminars to learn about the latest codes, technologies, and best practices. In summary, adding a second 480/1000 amp service requires careful planning and consideration. Potential issues include violation of electrical codes, overloading the transformer, increased fault current, grounding issues, and inductive interference. Specific issues related to engine dynos include short-circuit currents, reactive loads, and harmonics. It is essential to consult with a qualified electrical engineer, obtain proper permits, install appropriate equipment, coordinate with the utility company, and regularly maintain and inspect the electrical system. Attention to NEC compliance, load studies, short-circuit studies, grounding system design, and harmonic mitigation is critical for ensuring the safety and reliability of the electrical system. By following these recommendations, it is possible to safely and effectively add a second electrical service. Always prioritize safety and compliance when working with electrical systems. The NEC is the cornerstone of electrical safety in the United States, providing requirements for electrical installations to minimize hazards. Understanding and adhering to the NEC is crucial for protecting people and property from electrical dangers. Consulting with qualified professionals is always recommended when undertaking complex electrical projects. Electrical engineers and licensed electricians possess the knowledge and the experience necessary to ensure that electrical systems are designed, installed, and maintained safely and in accordance with applicable codes and standards. A proactive approach to electrical safety can help prevent accidents and ensure the long-term reliability of electrical infrastructure. Electrical systems should be regularly inspected and tested to identify potential problems before they lead to failures or hazards. Proper maintenance and repair can extend the lifespan of electrical equipment and improve overall system performance. In addition to the technical aspects of electrical installations, it is also important to consider the human factors. Electrical safety training should be provided to all personnel who work with or around electrical equipment. Clear and concise warning signs should be posted to alert people to potential hazards. Lockout-tagout procedures should be followed to prevent accidental energization of equipment during maintenance or repair. Electrical safety is a shared responsibility. Everyone has a role to play in preventing electrical accidents and ensuring the safe operation of electrical systems. By working together, we can create a safer environment for everyone. The installation of an engine dyno presents unique challenges due to the high power demands and potential for electrical disturbances. It is essential to carefully consider these factors when designing the electrical system to ensure that it can safely and reliably handle the load. The use of appropriate equipment and techniques can mitigate these challenges and ensure the safe operation of the dyno. Continuous monitoring of the electrical system can help detect potential problems early and prevent failures. Data logging and analysis can provide valuable insights into system performance and identify areas for improvement. In conclusion, adding a second 480/1000 amp service for an engine dyno is a complex undertaking that requires careful planning and execution. By addressing the potential issues and following the recommendations outlined above, it is possible to create a safe and reliable electrical system that meets the needs of the application. Remember to prioritize safety and compliance at all times and consult with qualified professionals for assistance. This ensures the successful integration of the new service and the safe operation of the engine dyno. Electrical systems are the backbone of modern society, providing the power that we rely on for so many aspects of our lives. It is essential to treat electrical systems with respect and to follow all safety precautions. By doing so, we can ensure that electrical systems continue to provide us with safe and reliable power for years to come. Keep in mind local codes and regulations and the latest edition of the NEC. They provide a roadmap for safe electrical installations, and adherence is paramount.